Hey guys, tonight we're embarking on a journey back in time, not with the time machine, but through nature's most incredible deep freeze. Imagine, if you will, vast, shimmering landscapes of ice and snow stretching further than the eye can see. A world where the air bites with an ancient chill, and beneath your feet, hidden for tens of thousands of years, lie perfectly preserved giants. You trudge across this endless white, your breath plumbing in frosty clouds, and with every step, you're walking over a natural time capsule, a silent museum of a world long gone. It's a place where a wrong step might mean a quick slide into an icy crevasse, and you probably won't survive the prehistoric elements yourself. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Now, dim the lights and let's ease into tonight's journey together. Our story, or rather our collection of stories, begins with the most iconic of all frozen prehistoric animals, the woolly mammoth. Picture this. It's the late 17th century, or maybe the early 18th, depending on which historical account you lean on. Traders and hunters, venturing into the vast, unforgiving expanses of Siberia, start reporting incredible finds. Not just bones, mind you, but entire carcasses emerging from the thawing permafrost. Can you imagine the sheer shock? It's not a skeleton from a museum, it's a creature with flesh, fur, and even organs, looking as though it just took a very long nap. One of the most significant early finds, often cited as the first scientifically documented mammoth carcass, was the Lena mammoth in 1799. A hunter discovered it eroding from a frozen cliff near the Lena River. For years, parts of it were scavenged, its tusks sold for ivory, before the German naturalist Michael Friedrich Adams finally retrieved the remains in 1806. He found a largely complete skeleton, remnants of skin and hair. It wasn't perfect, but it was enough to blow the scientific minds of the day. Up until then, the idea of such massive, long-extinct creatures was largely theoretical, based on scattered fossil evidence. This was concrete, fleshy proof. It challenged prevailing notions about the Earth's history and the stability of life forms. Scientists for centuries had struggled with the concept of extinction. The idea that an entire species could just vanish was a radical one. Many still believed in a fullness of nature, where no creature truly disappeared. The Lena mammoth, though, offered undeniable evidence of a past world populated by creatures unlike anything living today. Fast forward to the 20th and 21st centuries, and the discoveries become even more astonishing, thanks in part to improving excavation techniques and, ironically, the accelerating thaw of permafrost due to climate change. One of the most famous examples, and arguably the most complete woolly mammoth ever found, is Luba, a baby mammoth discovered in 2007 by a reindeer herder on the Yamal Peninsula in Siberia. Luba is a miracle of preservation. You look at her and she's almost perfectly intact. Her tiny trunk, her eyes, even the bristles of her fur, her internal organs, and milk still in her stomach. She's like a macabre ancient toy. She weighed about 50 kilograms and was roughly 1 month old when she died, likely suffocated in mud before being flash frozen. Her preservation is so pristine that scientists could even analyze her last meal, which consisted of her mother's milk, offering intimate details about the life of a prehistoric infant. Debate continues on whether the discovery of Luba, specifically, truly shifted public perception of prehistoric life more than previous finds, or if it was simply the culmination of accumulating evidence, but her sheer perfection certainly resonated. Imagine being the one to stumble upon something like Luba. You're just doing your daily rounds, maybe looking for lost reindeer, when you notice something unusual poking out of the thawing ground. It's not just a bone, it's a leg, a whole leg, with skin and hair. That moment of realization, of understanding that you're looking at a creature that walked the earth tens of thousands of years ago, is mind-blowing. It makes you feel incredibly small, doesn't it? And also incredibly connected to this ancient past. These finds aren't just scientific curiosities, they're emotional touchstones, reminding us of the fragility and grandeur of life on Earth. It's like finding a perfectly preserved, unopened snack from your great-great-grandparents' time, only this snack is the size of a small car and has fur. The preservation of these mammoths isn't just about the cold, it's a combination of factors. Rapid burial is key, often in soft sediments like mud or peat, which quickly encase the body and protect it from scavengers. Then, the immediate drop in temperature, freezing the carcass solid, prevents decomposition. It's a natural deep freeze, locking away not just the animal, but a snapshot of its environment. You can find pollen grains, insect remains, even undigested plant matter in their stomachs. It's like a prehistoric time capsule, meticulously cataloged by nature itself. These mammoths provide an incredible window into the Ice Age, telling us about the plants they ate, the diseases they might have suffered from, and even their genetic makeup, allowing scientists to piece together their evolutionary history. We've learned that mammoths were surprisingly diverse, with different populations thriving in various parts of their range. Some were true giants, others smaller. It's not just one big woolly elephant, it's a complex species with its own family tree. Moving on from the majestic woolly mammoth, we glide seamlessly into the world of another Ice Age giant, the woolly rhinoceros. Imagine a creature built like a tank, covered in shaggy, reddish-brown fur, sporting a massive, intimidating horn, or sometimes two on its snout. Unlike its modern African and Asian cousins, this rhino was perfectly adapted to the frigid, windswept grasslands of the steppe tundra, a landscape utterly alien to anything we see today. You're walking across a frozen plain, the wind whipping at your face, and suddenly a shadow falls over you. You look up and there it is, a woolly rhino, grazing stoically, its powerful frame radiating an ancient power. One of the most remarkable woolly rhino finds is Sasha, a young rhino calf discovered in 2014 in the Albaysky district of Yakutia, Siberia. Sasha is an astonishing specimen, estimated to be around 10,000 years old. Like Luba the mammoth, Sasha was incredibly well preserved, with much of her soft tissue, fur, and even a small horn intact. Imagine finding something like that. You'd think you'd stumbled into a prop room for a prehistoric movie, not a real-life scientific discovery. The sheer detail allowed scientists to study her fur color, which was a reddish-brown, distinct from the popular misconception of a grayish coat. This kind of detail, plucked from the permafrost, helps us repaint the picture of the past, adding vibrant color to what was once a black and white sketch. The find of Sasha was particularly significant because complete baby woolly rhinos are exceedingly rare. Previous discoveries were often partial skeletons or isolated bones, but Sasha offered a nearly perfect glimpse into the life of a young rhino. Another significant find, though less complete than Sasha, was the Storunia rhinoceros, discovered in a natural asphalt seep in Poland in 1907. While not frozen in ice, its preservation in oil-soaked clay offered a different kind of window into the past, preserving soft tissues and even muscle, preventing decay. This shows that nature has a few tricks up its sleeve when it comes to time capsules, not just the deep freeze. The Storunia rhino provided early crucial insights into the anatomy and external features of the species, long before the Siberian permafrost began yielding its perfect specimens. You might think, what's the big deal with a hairy rhino? But it's these minute details, the texture of the fur, the shape of the hooves, the specific wear on their teeth, that tell scientists stories about their lifestyle. Were they solitary or social? What did they eat? How fast could they run from a saber-toothed cat? Speaking of diet, the woolly rhinoceros was primarily a grazer. Their teeth were highly specialized for grinding tough grasses and sedges that covered the steppe tundra. You see them in your mind's eye, with their heads down, systematically mowing through the ancient vegetation. This dietary preference is a mainstream historical fact, supported by analyzing wear patterns on their teeth and the remnants of plant matter found in the stomachs of preserved specimens. This is where a quirky or fringe tidbit comes in. Some researchers have proposed that their massive horn wasn't just for defense. It might have also been used as a kind of snowplow, sweeping aside snow to reach the vegetation underneath during harsh winters. Imagine this giant beast not just looking formidable, but essentially being a living, breathing snow removal machine. It's a pretty clever adaptation if true, showing just how specialized these creatures were to their incredibly harsh environment. The precise function of the woolly rhino's horn, whether primarily for defense, foraging, or perhaps even a display of dominance, remains a topic of scientific discussion, isn't it? It's hard to know definitively without a living specimen to observe, isn't it? But the evidence from their remains, combined with comparative studies of modern rhinos, gives us pretty good clues. The size of their horns varied considerably, with some individuals boasting a horn over a meter long. This immense horn, made of keratin, the same stuff as your fingernails, would have been a formidable weapon against predators like cave lions and wolves. But it also begs the question, how much energy did it take to grow and maintain such a structure? And did horn size play a role in meeting displays, much like antlers in deer? Unlike mammoths, which had various close relatives still alive today, the woolly rhinoceros represents a wholly extinct genus, Coelodonta. This means there are no direct living descendants to observe and compare, making the insights from frozen remains even more invaluable. You look at a woolly rhino specimen, and you're not just looking at an ancestor, you're looking at the last of its kind. It's a sobering thought, isn't it? It reminds us that even the mightiest creatures can vanish from the face of the earth. Their disappearance, like that of many Ice Age megafauna, is a complex puzzle, likely a combination of climate change, habitat loss, and perhaps even early human hunting pressure. But the details locked within the ice continue to unravel the story of their lives and their ultimate demise. From the herbivorous giants of the Ice Age, we now turn our gaze to the apex predators, and few discoveries have been as captivating as the remarkably preserved cave lion cubs. Imagine trekking across the frozen wilderness, a biting wind whipping at your face, when you stumble upon a tiny, matted bundle poking out of the permafrost. You brush away the snow, and what emerges isn't just a skeleton, but a creature almost perfectly intact. A baby lion, its eyes closed as if merely sleeping. It's a surreal, heartbreaking sight, isn't it? In 2015, two incredible specimens named Uyan and Dina, though Dina later received the name Dinai, were discovered in the Uyandina River in Yakutia, Siberia. These weren't adult cave lions, which were themselves formidable beasts, much larger than modern African lions. These were cubs, mere weeks old when they died, some 30,000 years ago. Their preservation was astonishingly complete, with their soft tissues, fur, and even whiskers largely intact. It was as if they had simply curled up for a nap and frozen solid. Imagine the awe of the scientists carefully excavating these fragile bundles, knowing they were holding a perfect snapshot of prehistoric life. The mainstream historical fact is that cave lions, Panthera spelaea, were widespread across Eurasia and North America during the Ice Age, and these cubs offered the first truly detailed look at their early development. A year later, in 2017, an even more pristine cave lion cub named Boris was found in the same region, and then, in 2018, Spartak, another nearly perfect specimen, was unearthed. Spartak in particular was exceptional. It was so well preserved that researchers could discern its internal organs and even its whiskers. This level of detail allows scientists to piece together not just what these creatures looked like, but intimate details of their physiology and behavior. For instance, studying their fur helped confirm their reddish-brown coat, similar to modern lions but denser, providing insulation against the extreme cold. It's like finding a baby photo album from 30,000 years ago, and every picture is crystal clear. One quirky or fringe tidbit about these cave lion cub discoveries is the speculation surrounding their cause of death. While often attributed to mudslides or being trapped in thawing ice, some theories suggest they might have been deliberately buried by their mothers in denning sites that later became frozen. This idea, while harder to prove, paints a fascinating picture of maternal behavior in these ancient predators. You can almost imagine the desperate mother trying to protect her young from the encroaching cold or a sudden environmental disaster, unaware that her efforts would inadvertently create a perfect time capsule. Scientific discussion continues regarding whether the excellent preservation of these cubs points to specific environmental conditions at the moment of death, or if it was more a matter of sheer luck regarding their burial in permafrost. The study of these cubs has provided unprecedented insights into the life cycle of cave lions. We know they were born blind and helpless, just like modern lion cubs. Their teeth indicate their age, and the lack of wear suggests they hadn't started eating solid food yet. This tells us they were entirely dependent on their mother's milk, much like Luba the mammoth. By analyzing their DNA, scientists are also gaining a clearer understanding of their evolutionary relationship to other big cats, confirming their close ties to modern lions, but also highlighting their distinct lineage. It's like finding a distant relative you never knew you had, who turns out to be incredibly well-dressed and very, very old. These discoveries are particularly valuable because cave lions are an enigma in many ways. Unlike mammoths and woolly rhinos, we don't have direct modern counterparts that lived in the same extreme cold. Modern lions are creatures of the savanna. So, these frozen cubs help us understand how these massive felines adapted to the harsh conditions of the Ice Age steppe tundra. You consider their size, their powerful build, their massive canines. They were true kings of their prehistoric domain, fearlessly hunting large prey like young mammoths, bison, and horses. But even kings have vulnerabilities, especially when they're mere cubs. The fact that these little ones are so perfectly preserved offers a poignant reminder of the sheer power of nature to both create and to freeze in time. From the adorable, albeit ancient, cave lion cubs, we now journey across the vast Ice Age plains to encounter another magnificent beast of the past, the steppe bison. Imagine endless stretches of windswept grass, dotted with the occasional hardy shrub. And across this landscape, you see herds of these colossal bovines thundering past, their massive shoulders hunched, crowned with horns that dwarfed those of any modern bison. You feel the ground tremble beneath your feet as they pass, a raw, primeval power. The steppe bison, Bison priscus, was an iconic inhabitant of the mammoth steppe, a cold, dry grassland ecosystem that stretched across Eurasia and North America during the Pleistocene epoch. These weren't your average backyard cattle. They were formidable creatures, larger than modern American bison, with particularly impressive horns that could span over 6 feet from tip to tip. Their remains are frequently found in the permafrost, offering tantalizing glimpses into their lives. One of the most famous and incredibly preserved specimens is Blue Babe, an Alaskan steppe bison discovered in 1979 by gold miners near Fairbanks. Blue Babe isn't just a skeleton, it's a mummified carcass, approximately 36,000 years old, with much of its skin, muscle, and even some hair still intact. What makes blue babe particularly fascinating is not just its preservation, but the story of its demise. Scientists believe it was attacked by a pride of steppe lions, perhaps even ancestors of the very cubs we just discussed. And then, after falling into a muddy area, froze before being fully consumed. You can actually see claw marks on its hide and even remnants of lion teeth marks, offering a chillingly vivid snapshot of a prehistoric struggle for survival. It's like a police procedural from 36 millennia ago, with nature as the forensics team. The mainstream historical fact is that steppe bison were a primary food source for many Ice Age predators, and finds like blue babe provide direct evidence of these ancient predator-prey relationships. A quirky or fringe tidbit about blue babe involves the scientists who studied it. During the initial examination, after carefully thawing sections of the carcass, one of the paleontologists actually tasted a small piece of the ancient meat. Yes, you heard that right. He described it as having a very gamey flavor with an earthy aftertaste. Now, I'm not recommending you go out and try to find some ancient bison jerky, but it certainly adds a unique, if slightly unsettling, dimension to scientific inquiry, doesn't it? It just goes to show you how dedicated, or perhaps how curious, these researchers can be. Whether the consumption of ancient meat by scientists contributes meaningfully to research or is merely an anecdotal curiosity is still a point of discussion. Another significant steppe bison discovery is Yukagir bison, found in Yakutia, Siberia in 2011. This specimen, an adult bull, is also remarkably complete, with its brain, heart, and digestive system largely preserved. The level of detail from Yukagir bison allowed scientists to conduct an autopsy, revealing insights into its diet, health, and even parasites it might have carried. Imagine performing an autopsy on an animal that died before humans even invented the wheel. It's an unparalleled opportunity to study the paleobiology of an extinct species, providing data points that simply cannot be gleaned from bones alone. These frozen bison specimens challenge our understanding of ancient megafauna in several ways. For one, their sheer abundance in the fossil record, especially in permafrost regions, speaks to their success as a species. They were clearly well adapted to the harsh conditions of the Ice Age, thriving in numbers that supported a complex ecosystem of predators and scavengers. Their massive horns weren't just for show. They were formidable defensive weapons against the likes of cave lions and wolves, and likely also played a role in intermale combat during breeding season. You can almost hear the clash of horns echoing across the frozen plains. The study of their diet through stomach contents helps paint a picture of the prehistoric vegetation. By analyzing pollen and plant fragments, scientists confirm that these bison grazed on a diverse array of grasses and forbs, contributing to the health of the steppe ecosystem. These animals weren't just isolated figures, they were integral components of a complex web of life that existed for millennia before succumbing to the sweeping changes at the end of the last Ice Age. From the robust power of the steppe bison, we now shift our focus to something equally miraculous, but on a much more delicate scale: the discovery of an ancient foal. Imagine the Siberian permafrost, vast and desolate, slowly yielding its secrets. You're part of an excavation team, carefully chipping away at the icy soil, when suddenly a small, perfectly formed hoof emerges. Then a leg, then a tiny head covered in fine hair. What you're seeing isn't a fossilized bone, but a creature so perfectly preserved, it looks as though it could blink its eyes open at any moment. It takes your breath away, doesn't it? This incredible find occurred in 2018 in the Batagai Depression, also known as the Mouth of Hell, in Yakutia, Siberia. The foal, estimated to be between 30,000 and 40,000 years old, was a Lena horse, Equus lenensis, an extinct subspecies of horse. What makes this particular discovery so astonishing is its near complete preservation. You're not just seeing skin and bones, you're seeing internal organs, muscle tissue, and even its mane and tail hair. The mainstream historical fact is that various horse species roamed widely across the Ice Age landscapes, but finding such a complete specimen provides an unparalleled window into their biology. It's like discovering a perfectly preserved baby photo of a species thought lost to time. The foal, named Spartak by some researchers, though it shares a name with one of the cave lion cubs, leading to occasional confusion, was only about 2 months old when it died. Scientists believe it likely drowned after getting stuck in a natural trap like a mud pit, which then froze solid, preserving it flawlessly. You can almost picture the scene, a frantic mother whinnying nearby, unable to rescue her young. The mud encased the tiny body, protecting it from scavengers and the elements. Then the deep freeze of the permafrost took over, locking it away for millennia. The fine details are what truly astound. You can make out the individual hairs on its body, the folds of its skin, even the delicate eyelashes around its eyes. It looks soft and vulnerable even after all this time. A quirky or fringe tidbit related to this foal is the discussion among scientists about potentially extracting viable DNA for the extinction efforts. While still highly speculative and ethically complex, the exceptional preservation of this foal's soft tissues and organs raises the tantalizing possibility of one day bringing back extinct species. Imagine a world where woolly mammoths and ancient horses once again roam. It sounds like something out of a science fiction movie, right? But the quality of the genetic material from finds like this brings it one step closer to being a scientific possibility. Whether the scientific pursuit of de-extinction is a responsible use of resources given current conservation challenges for living species remains a point of considerable debate. The detailed analysis of the foal has yielded a wealth of information. Its dark brown coats with a black mane and tail suggest the coloring of these ancient horses was quite similar to some modern breeds. Scientists have examined its stomach contents, providing direct evidence of its diet, mother's milk, confirming its young age, and surprisingly, some soil particles, suggesting it may have been rooting around or perhaps ingested mud before its demise. This kind of direct evidence is invaluable, as it paints a far more accurate picture than could ever be inferred from skeletal remains alone. It helps us understand the ancient environment, the diet of its mother, and the early life stages of these prehistoric equines. These ancient horses were hardy creatures, well adapted to the harsh conditions of the mammoth steppe. They were smaller and stockier than many modern horses, built for endurance. They were a crucial part of the Ice Age ecosystem, serving as prey for predators like the cave lions and wolves we've discussed, and playing a role in shaping the vegetation through their grazing. The discovery of such an intact foal reminds us of the delicate balance of life in these ancient worlds, and the sudden, often tragic ways in which individual lives could end, only to be preserved as a perfect time capsule for future generations to marvel at.
As we journey deeper into the frozen past, we transition from the swift grace of ancient horses to the cunning intelligence of the Ice Age wolf. Imagine the bitter cold of the tundra, the snow muffling all sound except the whisper of the wind and the distant howl of a pack. You're bundled in heavy furs, hunkered down, and suddenly, through the swirling snow, you catch a glimpse of a gaunt, powerful form, its eyes gleaming with ancient predatory instinct. This is the Ice Age wolf, a creature both familiar and starkly different from its modern descendants. The discovery of remarkably preserved wolf pups in Siberia has provided an unparalleled window into the lives of these ancient canids. In 2015, two incredibly well-preserved wolf pups named Dogor, meaning friend or companion in Yakut, and Wolfie, informal but commonly used, were found in the Abiysky district of Yakutia. Dogor, found near the Syalach River, is estimated to be around 14,000 years old, while Wolfie from the Tirektiach River is even older at approximately 18,000 years. Both pups were found almost entirely intact, with their fur, soft tissues, and even whiskers amazingly preserved. Imagine excavating something so fragile, yet so perfectly a relic of a bygone era. It's like holding a piece of living history in your hands. The mainstream historical fact is that wolves, Canis lupus, were incredibly widespread during the Ice Age, thriving alongside the megafauna they preyed upon. These ancient wolves, often larger and more robust than modern wolves, were key predators in the steppe tundra ecosystem. The preserved pups offer direct evidence of their physical characteristics, their coat color, often a mottled gray-brown, and even insights into their early development. Dogor, for instance, was so well preserved that DNA analysis revealed it to be a male, and scientists could even speculate on its cause of death, likely a den collapse or being buried in a mudslide. It paints a vivid, if tragic, picture of life and death in the Ice Age. A quirky or fringe tidbit surrounds Dogor specifically. Its remarkable preservation led to DNA analysis that placed it genetically close to the common ancestor of both modern wolves and domestic dogs. This fueled fascinating discussions, and some preliminary reports even suggested it might represent a very early lineage that diverged before the full domestication of dogs. While the consensus now leans towards it being a true wolf, the initial excitement about its potential role in dog domestication was a testament to how these frozen finds can shake up long-held theories. The impact of these specific wolf finds on our understanding of early dog domestication continues to be explored, providing additional data points within a complex genetic puzzle. The study of these wolf pups has also shed light on their diet and health. Analysis of their stomach contents and gut parasites, when possible, provides direct evidence of what they ate and what ailments they suffered from. For instance, finding remnants of small mammals or even pieces of larger prey in the stomach of an ancient wolf pup gives us tangible proof of the Ice Age food web. It's like finding a detailed grocery list from 18,000 years ago, complete with ancient snacks. These Ice Age wolves were formidable hunters, often operating in packs to take down large prey like reindeer, horses, and even young mammoths or bison. Their success was intertwined with the abundance of megafauna. Their physical adaptations, from their powerful jaws to their dense fur, made them perfectly suited to survive and thrive in the brutally cold environment. You can almost hear their coordinated howls echoing across the frozen landscape. Their existence reminds us of the delicate balance within these ancient ecosystems, where every creature, from the smallest rodent to the largest mammoth, played a crucial role. The survival of the wolves depended directly on the health and numbers of their prey, creating a dynamic, often brutal, but ultimately sustainable prehistoric dance of life. Having delved into the world of Ice Age predators, it's time to confront a creature that sounds like it stepped right out of a fantasy novel: the Siberian unicorn, or more accurately, Elasmotherium sibericum. Imagine a world where rhinos aren't just rhinos, but colossal, shaggy beasts. Not with a horn or two on their nose, but with a single, massive, impressive horn jutting from their forehead. You stand before it, an awe-inspiring presence, its sheer bulk a testament to the power of prehistoric life. For a long time, the Siberian unicorn was known primarily from scattered fossil bones and teeth, leading to speculation about its exact appearance and size. It was thought to have gone extinct much earlier than other Ice Age megafauna. But then, discoveries in the permafrost began to reveal a different story. The mainstream historical fact is that the Elasmotherium was a genus of enormous rhinos, far larger than any living rhino today. and characterized by a single, exceptionally large horn on its forehead. They were, in essence, the real-life unicorns, albeit much hairier and less delicate than the mythical ones. In 2016, a particularly significant find occurred in the Pavlodar region of Kazakhstan, a remarkably well-preserved skull of an Elasmotherium sibiricum. While not a full carcass like some of the other finds we've discussed, its excellent condition, still partially encased in ice and permafrost, allowed for precise dating. This skull, nicknamed the Pavlodar unicorn, was dated to approximately 29,000 years ago. This date was a major surprise because it indicated that these unicorns coexisted with early modern humans and persisted much longer in southwestern Siberia than previously thought. Before this, the prevailing scientific consensus was that they had largely died out much earlier, around 350,000 years ago. So, the ice once again rewrote history, pushing the timeline of these magnificent beasts far closer to our own. You might be thinking, wait, so humans actually saw these things? Yes, they most likely did. A quirky or fringe tidbit about the Siberian unicorn is how its unique horn, unlike the typical rhino horn composed of keratin, might have been formed. While mostly keratin, some theories suggest a bony core, or at least a very strong bony attachment point on the skull to support its enormous weight. Imagine trying to balance a 5-foot-long heavy horn on your forehead. It would need a serious foundation. This structure would have made the horn incredibly strong, perhaps used for digging for roots and grasses in frozen ground, or for fighting off rivals or predators. The primary function of the Elasmotherium horn, whether for defense, display, or foraging, is still a subject of scholarly debate. It's difficult to say for sure, but its sheer size suggests it played a critical role in their survival. These unicorns were enormous, estimated to weigh up to 4 tons and stand over 2 meters tall at the shoulder. They were true giants of the steppe. Unlike the woolly rhinoceros, which preferred grasses, Elasmotherium is thought to have been a grazer of tough, dry vegetation. Their massive teeth were adapted for processing fibrous plants. You picture them, heads down, systematically stripping the ancient landscape of its hardy plants, a living, breathing lawnmower on a truly epic scale. The very existence of these animals and their surprising late survival highlights how much we still have to learn about the prehistoric world. Every time the permafrost yields a new secret, it forces scientists to reevaluate established timelines and theories. It's like finding a new chapter in a history book you thought you'd finished. The fact that a creature so large and distinctive could have such a protracted and debated extinction timeline reminds us that the past is far from a settled story. And to think, for a while they were considered just a collection of old bones, slowly re-emerging from the earth, only to now be seen as a species that perhaps inspired some of humanity's earliest myths. Who knows what other mythical beasts might one day emerge from the ice, proving that sometimes reality is stranger and hairier than fiction. From the fleeting glimpses of ancient birds, we now lift our gaze from the massive mammals to something equally fascinating yet far more delicate: prehistoric birds. Imagine the vast, silent landscapes of the Ice Age, the air crisp and cold, and above you, against the pale, immense sky, the flutter of ancient wings. You crane your neck, trying to catch a glimpse of feathers, an echo of life thousands of years old. While complete fleshy birds are much rarer finds in the permafrost compared to mammoths or rhinos, the discoveries that have occurred are no less remarkable. The mainstream historical fact is that birds have been an incredibly successful and diverse group of animals for millions of years, adapting to nearly every environment on Earth, including the harsh conditions of the Ice Age. The challenge with avian fossils is their fragile, hollow bones, which don't preserve as well as the dense bones of mammals. However, the unique conditions of permafrost can sometimes defy these odds. One of the most significant avian finds came in 2018, when a remarkably preserved specimen of a shrew-like bird, later identified as a precursor to modern larks or sparrows, was discovered in the Zyryanka area of Yakutia, Siberia. This tiny bird, estimated to be around 46,000 years old, was found mummified and almost entirely intact, with its feathers, claws, and even soft tissues largely preserved. Imagine finding something so small, so delicate, frozen in such perfect detail for tens of thousands of years. It's like discovering a perfectly preserved feather from a truly ancient and forgotten age. This tiny bird offered unprecedented insights into avian evolution during the Pleistocene, providing a direct link to the birds that flitted across the Ice Age landscapes. A quirky or fringe tidbit concerning these avian discoveries involves the surprising colors of some of the preserved feathers. While many might imagine Ice Age creatures to be drab and muted in color, analysis of some fossilized feathers, even those not from full permafrost mummies, sometimes hints at iridescent qualities or surprisingly vibrant hues. For example, researchers studying ancient feather structures have found evidence of melanosomes, pigment-containing organelles that could produce various colors, even iridescent ones. So, it's possible these ancient birds weren't just brown and gray. They might have sported flashes of blue, green, or even purple, just like some modern birds. Whether the perceived dullness of prehistoric animal depictions is a true reflection of their appearance, or merely a limitation of fossil evidence before advanced analytical techniques, continues to be a point of scholarly discussion. Another intriguing discovery, though not a complete bird carcass, involves preserved feathers and even parts of ancient nests found in permafrost. These fragments, while small, offer crucial clues about the types of birds that inhabited the Ice Age steppe tundra. They confirm the presence of species adapted to cold, open environments and provide information on their nesting behaviors. You might think, just a feather? What's the big deal? But a single feather can contain a wealth of information. Its structure tells us about flight, its color about camouflage or display, and DNA extracted from its quill can link it to living relatives. These feathered finds challenge our understanding of avian evolution. By studying the morphology of these ancient birds, scientists can trace the lineage of modern species, identifying how specific adaptations for flight, foraging, and survival in extreme cold developed over millennia. They show us that the skies above the mammoths and rhinos were not empty, but filled with a diverse array of avian life, each playing its role in the ancient ecosystem. From small songbirds navigating the ancient winds to larger raptors circling overhead, searching for prey, the Ice Age skies were alive. The sheer difficulty of finding such well-preserved avian remains makes each discovery a treasure. It speaks to the extremely rare conditions required for their mummification. Often, they would need to be rapidly buried, protected from scavengers, and then immediately flash frozen, perhaps caught in a sudden snowstorm or trapped in ice. These tiny fragments of feathered life, emerging from the deep freeze, remind us that the story of the Ice Age isn't just about the colossal giants, but also about the smaller, often overlooked creatures that shared their world, their lives just as vital, and their existence just as precarious in that ancient, frozen epoch.
From the fleeting glimpses of ancient birds, we now stalk the elusive and enigmatic Beringian lynx. Imagine yourself a lone hunter, traversing the vast, snow-covered expanses of what was once the Beringian land bridge connecting Siberia and Alaska. The air is frigid, and the silence is profound, broken only by the crunch of your boots on the snow. Suddenly, a flicker of movement in the distance, a ghost in the white landscape, a prehistoric feline, perfectly camouflaged, observing you with piercing eyes before melting back into the frozen wilderness. The Beringian lynx, Lynx canadensis subsolana, or a closely related extinct subspecies, represents a fascinating chapter in the history of prehistoric felines. While not as widely publicized as mammoths or cave lions, the occasional discovery of well-preserved lynx remains in the permafrost offers crucial insights into the diversity of prehistoric cat species and their dispersal across ancient land bridges. The mainstream historical fact is that the Bering Land Bridge, or Beringia, was a vital pathway for the movement of animals and early humans between continents during glacial periods, and lynx were among the creatures that crossed it. One notable, though rare find, was a partial mummified carcass of a lynx discovered in the Yukon Territory, Canada, dating back tens of thousands of years. While not a complete, pristine specimen like some other finds, its preservation allowed for detailed morphological study and genetic analysis. Imagine the thrill of uncovering even a part of such a creature, knowing it prowled the same frigid landscapes that would one day become modern-day Alaska and Yukon. These finds confirm that lynx, adapted to cold environments, were successful inhabitants of Beringia, preying on snowshoe hares and other smaller mammals that thrived in the boreal forests and tundra patches. A quirky or fringe tidbit concerning the Beringian lynx revolves around its subtle differences from modern Canadian lynx. While genetically very similar, some morphological studies of their skeletal remains, particularly skull shape and tooth wear, suggest slight adaptations to their Ice Age environment, possibly indicating a preference for slightly different prey sizes or hunting strategies. It's like comparing two very similar models of the same car, but one has slightly tweaked suspension for rougher terrain. Whether these subtle morphological differences warrant classification as a distinct subspecies, or if they represent natural variations within the broader Lynx canadensis species, is still a matter of scientific exploration. The debate highlights the ongoing challenge of classifying ancient animals based on limited physical evidence. The significance of these Beringian lynx finds lies in their contribution to understanding faunal exchange between continents. As sea levels dropped during glacial maximums, the Bering Land Bridge emerged, creating a wide, ice-free corridor. Animals like mammoths, woolly rhinos, bison, wolves, and of course lynx used this bridge to migrate, shaping the biodiversity of both North America and Eurasia. The presence of a distinct Beringia lynx lineage provides a tangible link to this ancient migratory pathway, demonstrating how species moved and adapted across vast interconnected landscapes. These ancient lynx were expert hunters, perfectly suited to their snowy domain. Their large, heavily furred paws acted like natural snowshoes, distributing their weight and allowing them to move silently and efficiently over deep snow. Their keen eyesight and acute hearing, along with their ambush hunting style, made them formidable predators of the smaller game that sustained them. You picture them crouched low, waiting patiently before a sudden, explosive pounce on an unsuspecting hare. Their success in such a harsh environment speaks volumes about their evolutionary prowess. Every time a piece of a Beringian lynx emerges from the permafrost, it offers another puzzle piece to the grand tapestry of Ice Age life. It reminds us that the vast, seemingly empty stretches of ice and snow were teeming with life, from the smallest voles to the largest megafauna, and that the predators, like the lynx, played an essential role in maintaining the delicate balance of this ancient ecosystem. These quiet, patient hunters were truly masters of their frozen domain, their ghost-like presence a testament to the enduring adaptability of life. From the stealthy lynx, we now burrow into the world of another tenacious survivor of the Ice Age, the wolverine. Imagine the biting Arctic wind, the ground iron-hard with frost, and through the snow, a low, powerful creature, utterly unafraid, relentless in its pursuit. You watch it, a compact bundle of muscle and ferocity, demonstrating a resilience that defies its relatively small size. This is the wolverine, an ancient survivor whose lineage stretches back through millennia of cold. While not as grand in scale as a mammoth or as charismatic as a cave lion, the discovery of ancient wolverine remains in permafrost has provided crucial insights into their long evolutionary history and their remarkable adaptation to harsh environments. The mainstream historical fact is that wolverines, gulo, are known for their incredible toughness and ability to thrive in extreme cold, scavenging and hunting in environments where few other predators can survive. Their range today still includes the Arctic and subarctic regions, making them living links to the Ice Age. One particularly significant find was a mummified head of an ancient wolverine discovered in 2018 in the Yukon Territory, Canada. This specimen, estimated to be around 27,000 to 30,000 years old, was remarkably well preserved, with its fur, skin, and even some facial features intact. Imagine holding a piece of a creature that looked out at the Ice Age world with those very eyes. It's a humbling thought, connecting you directly to a time before recorded history. The find allowed scientists to compare its morphology with modern wolverines, confirming their deep evolutionary roots and highlighting their consistent adaptation to cold, snowy conditions over tens of thousands of years. They haven't changed much because what they do incredibly well. A quirky or fringe tidbit about these ancient wolverines, and indeed their modern counterparts, is their astonishing ability to take down prey far larger than themselves. While they are often associated with scavenging carrion left by larger predators, Ice Age wolverines, like their modern relatives, were likely capable of bringing down animals as large as reindeer or even young bison, particularly if the prey was injured or weakened by harsh conditions. Imagine this relatively small animal, with its disproportionately powerful jaws and claws, engaging in a battle with a much larger beast. It paints a picture of extreme tenacity. The wolverine's primary role in the Ice Age ecosystem, whether as a scavenger or an active predator, or if its strategy shifted based on prey availability and climate, continues to be a subject of scientific inquiry. The preserved remains, even just a head, offer valuable genetic material. DNA extracted from these ancient wolverines helps scientists understand their population dynamics during the Ice Age, their genetic diversity, and their dispersal patterns across continents. It allows us to trace their family lineage back through the glacial periods, revealing how they spread across Eurasia and into North America. It's like tracing your own family lineage, but on an epic geological scale. The wolverine's adaptations to the cold are truly impressive. Their thick, dense fur is incredibly insulating, and their large padded paws provide excellent traction and act like snowshoes, preventing them from sinking too deep in the snow. They possess an incredibly powerful bite, capable of crushing bone to access marrow, a vital source of nutrients in a lean environment. You can almost hear the crunch as it gnaws on a frozen carcass, making the most of every morsel. They are solitary creatures for the most part, but their individual strength and resourcefulness make them formidable survivors. These Ice Age wolverines were an integral, if perhaps less noticed, component of the ancient ecosystem. They helped to clean up carcasses, preventing the spread of disease, and were opportunistic predators that kept prey populations in check. Their continued presence today, virtually unchanged from their prehistoric ancestors, serves as a testament to the effectiveness of their evolutionary design. They are the unsung heroes of the Ice Age, proving that sometimes being small, tough, and incredibly stubborn is the best strategy for long-term survival. Having marveled at the individual prehistoric giants and tenacious survivors frozen in time, it's now crucial to connect their stories to our own. We shift from the animals themselves to the fascinating, sometimes haunting, evidence of early human discoveries, coexisting with giants. Imagine yourself as an early Homo sapiens, newly arrived on these vast, frigid plains, armed with little more than ingenuity, fire, and sharpened stone. You're not just a passive observer of this incredible wildlife, you're sharing the landscape with them, hunting them, fearing them, and perhaps even admiring them.
The mainstream historical fact is that early modern humans, and indeed some of our hominin cousins like Neanderthals, lived alongside and interacted with the very megafauna we've been discussing. They weren't just curious about these immense creatures. Their survival often depended on understanding and exploiting them. Evidence of this coexistence isn't found in perfectly preserved human bodies in the permafrost, sadly, but in the archaeological record, tools crafted from mammoth ivory, bones bearing cut marks from stone blades, and the awe-inspiring cave art depicting these very animals. You can almost feel the presence of our ancestors in these sites, their breath pluming in the same ancient air, their eyes fixed on the same incredible beasts. One of the most striking examples of this coexistence comes from sites like Sungir in Russia, dating back around 34,000 years, where elaborate burials of early modern humans were discovered. These individuals were adorned with thousands of mammoth ivory beads, carved pendants, and even spears straightened from mammoth tusks. Imagine the skill and effort required to craft such intricate objects from the enormous tusks of these extinct giants. It tells us that mammoths weren't just food, they were a central part of human culture, spirituality, and artistic expression. It's like finding a 34,000-year-old jewelry store stocked entirely with mammoth bling. A quirky or fringe tidbit involves the possibility that some of the earliest human myths and folklore might have been inspired by encounters with these colossal creatures, particularly those emerging from the melting ice. Think about the legends of giants or monstrous beasts found in various ancient cultures. Could the sight of a partially thawed mammoth with its long tusks and hairy hide have fueled such tales? While purely speculative, it's a fascinating thought that the very act of the ice yielding its secrets might have, in ancient times, sparked our ancestors' imaginations in profound ways. The influence of large, unusual fossil remains on early human mythology and whether such narratives developed independently from common cultural archetypes remains a topic of scholarly discussion. Beyond the cultural aspects, there's the undeniable evidence of human hunting. Sites like the Clovis culture sites in North America or numerous Paleolithic sites across Eurasia contain ample evidence of mammoth and bison kills. You find scatters of stone tools alongside the disarticulated bones of megafauna, often with clear cut marks where flesh was removed or fracture patterns indicating marrow extraction. Our ancestors, despite their rudimentary technology, were remarkably efficient hunters, sometimes even driving entire herds off cliffs or into natural traps to secure enough meat to last through the brutal Ice Age winters. It paints a picture of cunning, courage, and a deep understanding of animal behavior. The existence of Ice Age animals shaped early human migration and settlement patterns. Humans followed the herds, adapting their technologies and lifestyles to the resources provided by the megafauna. Mammoth bones were used to construct dwellings in regions where wood was scarce, offering warmth and shelter from the elements. You see the circular arrangements of massive bones, remnants of these ancient homes, and you can almost hear the crackle of fire within, a small beacon of human ingenuity in a vast, frozen world. These ancient interactions were not always harmonious. While humans revered these animals, they also hunted them, and some theories suggest that human hunting pressure, alongside rapid climate change, played a significant role in the ultimate extinction of many Ice Age megafauna. It's a sobering thought that our ancestors, in their struggle for survival, might have contributed to the disappearance of the very giants that sustained them. But it also highlights the profound and undeniable connection between humanity and the natural world, a connection that began tens of thousands of years ago on the frozen plains. Having understood the incredible natural processes that freeze these prehistoric treasures, let's now turn our attention to the human ingenuity that unlocks their secrets. Preservation secrets, why ice is the ultimate time capsule. Imagine the Earth itself as a colossal, ancient refrigerator humming silently through the millennia, carefully holding its precious contents for future discovery. The mainstream historical fact is that the primary agent of this extraordinary preservation is permafrost, permanently frozen ground. Permafrost is soil, rock, or sediment that remains below 0 degrees Celsius, 32 degrees Fahrenheit, for at least 2 consecutive years. In vast regions of Siberia, Alaska, Canada, and parts of northern Europe, permafrost extends for hundreds of meters deep, essentially creating a vast natural freezer. You walk across this seemingly solid ground, but beneath your feet lies a silent, icy vault, holding secrets of an unimaginable age. But it's not just the cold itself. The unique conditions that create these perfectly preserved mummies are a confluence of factors. First, rapid burial is absolutely crucial. An animal must die and be quickly covered, often by fine-grained sediment like mud, silt, or peat. This rapid burial protects the carcass from scavengers. Remember Blue Babe, the bison, partially eaten by lions before it froze, and from the destructive forces of weather and erosion. Imagine a mammoth calf like Luba slipping into a muddy riverbed and sinking quickly. The mud encases it, shutting off oxygen. Second, the immediate and sustained freezing is vital. Once buried, the temperature must drop below freezing and stay there consistently. The cold slows down and eventually halts the activity of bacteria and enzymes that cause decomposition. Without oxygen and without the biological processes of decay, the body is essentially put into a state of suspended animation. It's like hitting the pause button on a video, only the video is tens of thousands of years long. This is why you don't find many frozen animals in temperate regions. Even if they freeze, they'll thaw seasonally, allowing decay to resume. A quirky or fringe tidbit about permafrost is the discovery of ancient viruses and bacteria along with the animals. While often dormant, some of these microorganisms have been successfully revived in labs. Imagine finding a virus that hasn't seen the light of day for 30,000 years, still capable of replication. This raises fascinating and sometimes concerning questions about what else might be locked away in the ice. Scientists are very cautious with these finds, of course, to prevent any unintended releases. Whether the potential scientific insights gained from ancient microbes outweigh the inherent, albeit small, risks associated with their retrieval and study remains a subject of ongoing discussion. Another form of glacial preservation, though less common for complete carcasses, is being trapped in ice sheets or glaciers. While these typically crush and dismember larger animals, sometimes smaller creatures or parts of animals can be encased and preserved. The ice itself acts as a protective barrier, preventing oxygen exposure and physical degradation. Think of the Iceman, Otzi, a human mummy found in an alpine glacier, although he's much more recent than our megafauna. His preservation, while not in permafrost, demonstrates the power of glacial ice as a preservative. The sheer stability of deep permafrost is what makes it the ultimate time capsule. Layer upon layer of sediment and ice builds up over millennia, creating a stable sub-zero environment. This consistency is key. Any significant thawing and refreezing cycles would damage the delicate tissues, leading to decomposition. This is why many discoveries occur as the permafrost begins to thaw, revealing the perfectly preserved remains as the protective layer of ice recedes. The contents of these time capsules are not just the animals themselves. As we discussed with the ancient foal stomach contents, the surrounding environment is also preserved. Pollen, seeds, insect fragments, and even ancient microbes are locked within the same icy matrix. This allows scientists to reconstruct entire ancient ecosystems, understanding the climate, vegetation, and biodiversity that existed tens of thousands of years ago. It's a complete environmental snapshot, far richer than any fossil record alone could provide. The ice doesn't just preserve life, it preserves an entire world. Having understood the incredible natural processes that freeze these prehistoric treasures, let's now turn our attention to the human ingenuity that unlocks their secrets. Scientific methods unlocking ancient DNA. Imagine a pristine ancient specimen unearthed from its icy tomb. It looks almost alive, but it's also incredibly fragile. A biological puzzle box holding genetic information that could rewrite history. You're watching scientists, armed with specialized tools and cutting-edge technology, meticulously extract the invisible threads of life from these long-dead creatures. The mainstream historical fact is that advances in genetic sequencing have revolutionized paleontology, allowing scientists to extract and analyze ancient DNA, aDNA, from fossilized and mummified remains. This was once a dream, confined to science fiction, but now it's a reality, providing unprecedented insights into evolution, population dynamics, and even the causes of extinction. You can picture the sterile laboratory, the hushed concentration of researchers as they work with samples that are literally tens of thousands of years old. The process of extracting aDNA is incredibly challenging. The DNA molecules, while remarkably preserved in the cold, are still degraded and fragmented over millennia. They are also highly susceptible to contamination from modern DNA, from bacteria, fungi, or even the scientists themselves. Think of trying to find a few specific grains of sand on a vast beach, while also making sure no new sand gets added. So scientists work in highly controlled, clean room environments using specialized reagents and techniques to minimize contamination and maximize the yield of ancient genetic material. A quirky or fringe tidbit concerns the ethical debates surrounding the potential for de-extinction, spurred by the recovery of viable ancient DNA fragments. While a complete, perfectly preserved genome of a mammoth or other extinct animal has yet to be found, the increasing quality of recovered DNA, especially from specimens like the ancient foal or luba the mammoth, fuels discussions about using cloning or gene editing technologies to bring these species back. Imagine a modern lab trying to piece together a fully functional genome from millions of tiny broken fragments. It's a monumental task, but the very possibility ignites both scientific excitement and considerable ethical hand-wringing. Whether the pursuit of de-extinction is a viable conservation strategy given the ecological complexities and resource demands, or primarily a fascinating scientific experiment, continues to be a point of considerable debate. Once extracted, the ancient DNA is then sequenced, meaning its precise order of chemical bases, A, T, C, and G. This genetic code is then compared to the DNA of living relatives, like modern elephants for mammoths or modern wolves for Ice Age wolves. This comparative genomics allows scientists to build detailed family trees, understanding the evolutionary relationships between extinct and living species. You learn about migrations, bottlenecks in population size, and even adaptation to specific environments based on genetic markers. For example, some studies have identified genes in woolly mammoths linked to hair growth, fat metabolism, and cold tolerance, direct genetic evidence of their adaptations to the Ice Age climate. Beyond DNA, other scientific methods are employed. Radiocarbon dating, carbon-14 dating, is essential for determining the age of the specimens, providing a precise timeline for their existence. Isotope analysis of teeth and bones can reveal dietary information and even migratory patterns, what they ate and where they roamed. CT scans and MRI scans allow scientists to visualize the internal structures of mummified animals without damaging them, peering inside ancient brains, hearts, and lungs. It's like having an X-ray machine that can see through 30,000 years of ice. These combined scientific approaches transform a frozen carcass from a mere curiosity into a treasure trove of biological and ecological data. Each discovery, each new technique adds another layer to our understanding of a world that existed long before us, providing answers to questions that were once unanswerable. The ice may preserve the body, but it is science that breathes life back into the story of these incredible prehistoric creatures. We've explored the wonders of what the ice has preserved and how science unravels its secrets. Now, let's pivot to a more sobering, yet equally vital, aspect of these discoveries: climate change warnings. Melting ice reveals more. Imagine the vast, stable sheets of permafrost, once the Earth's most reliable deep freezer, now beginning to crack and soften.
You can almost hear the groaning of ancient ice as it gives way, not just revealing past life, but whispering warnings about our future. The mainstream historical fact is that the Earth's climate is warming at an unprecedented rate, largely due to human activity. And this warming is having a profound impact on the planet's cryosphere, its frozen parts. The Arctic is warming at a rate 2 to 3 times faster than the global average. You don't need a degree in glaciology to see the changes. Receding glaciers, shrinking ice caps, and, most relevant to our story, the thawing of vast areas of permafrost. This phenomenon, while devastating in its implications, is ironically also leading to an increase in the discovery of new frozen specimens. It's a bittersweet paradox. The destruction of the natural freezer is revealing its contents. As the permafrost thaws, the protective layer of ice and frozen soil that has encased these ancient animals for millennia begins to melt. This exposes the carcasses to the elements and to modern biological activity, leading to rapid decomposition if not retrieved quickly. Imagine a freezer door left ajar and all its contents slowly beginning to spoil. Many discoveries now occur not through planned scientific expeditions, but opportunistically by local reindeer herders, hunters, or gold miners who stumble upon remains newly exposed by the melting ground or eroding riverbanks. This means a race against time to recover and study these finds before they degrade. A quirky or fringe tidbit, often discussed with a mix of fascination and unease, is the potential for the release of ancient pathogens from thawing permafrost. We briefly touched on this when discussing ancient viruses. Scientists have indeed revived dormant bacteria and viruses, including some that cause anthrax, from ancient animal carcasses, and even from the permafrost itself. While the immediate risk to human health is generally considered low for common ancient pathogens, the emergence of entirely unknown paleoviruses is a subject of ongoing research and theoretical concern. Imagine a prehistoric superbug kept on ice for tens of thousands of years suddenly awakening. It sounds like a bad movie plot, doesn't it? Whether the media's portrayal of zombie viruses from permafrost exaggerates the actual scientific risk or serves as a valid warning about potential future health challenges continues to be a point of discussion. Beyond the biological implications, the thawing permafrost also has significant environmental consequences. It releases vast amounts of greenhouse gases, methane and carbon dioxide, that were previously trapped in the frozen organic matter. This creates a dangerous feedback loop. Warming temperatures thaw the permafrost, which releases more greenhouse gases, which in turn leads to more warming, and so on. You can almost feel the Earth sighing out these ancient breaths, exacerbating the very problem that's revealing the Ice Age past. The increasing frequency of these discoveries, while exciting for paleontologists, serves as a stark reminder of the accelerating pace of climate change. Each perfectly preserved mammoth, each ancient wolf pup emerging from its icy tomb is a visual, tangible manifestation of a changing planet. They are literally the canaries in the coal mine, telling us that something fundamental is shifting beneath our feet. These discoveries are not just about looking back, they are about understanding the present and preparing for the future. By studying how ancient ecosystems responded to past climate shifts, scientists can gain crucial insights into how modern ecosystems might react to ongoing warming. The very act of uncovering these long-dead creatures forces us to confront the living, breathing crisis of our own time. They are silent, fur-covered messengers from the past, urging us to listen to the Earth's warnings before the ultimate time capsule is entirely melted away. As our journey through the frozen past draws to a close, we arrive at a point of quiet contemplation. Future discoveries. What else lies frozen? Imagine the vast, unexplored stretches of the Arctic and subarctic, still largely untouched by human hands, still holding secrets beneath their icy mantle. You stand on the edge of this immense, frozen frontier, knowing that beneath the surface, countless wonders of a prehistoric world remain hidden, waiting for the gentle nudge of a scientific probe, Or perhaps the accelerating thaw of a changing climate. The mainstream historical fact is that only a tiny fraction of the world's permafrost regions has been thoroughly explored for ancient remains. The sheer scale of these frozen landscapes, combined with the often challenging and remote conditions for excavation, means that the vast majority of what lies buried is still undiscovered. You consider the immense area, vast swaths of Siberia, Alaska, and Canada, much of it wilderness, a silent library of Earth's history locked away in ice. Every new find, therefore, isn't just a single discovery, it's a tantalizing glimpse of the countless more that must exist. The increasing rate of permafrost thaw, as we just discussed, paradoxically means that more of these specimens are coming to light, often serendipitously. This raises the tantalizing prospect of what else could be preserved. Could we find an entirely new species of Ice Age megafauna, one currently unknown from the skeletal fossil record? Perhaps a creature whose soft tissues were too delicate to fossilize in other environments, but which the ice perfectly preserved. Imagine unearthing a complete woolly rhinoceros family or a perfectly mummified cave bear. The possibilities are truly boundless, limited only by the extent of the frozen ground. A quirky or French tidbit, often whispered among paleontologists, is the enduring hope of finding a perfectly preserved saber-toothed cat. While remains of Smilodon, the North American saber-toothed cat, and other saber-toothed species have been found, a full, soft-tissue preserved specimen like Luba the mammoth remains the holy grail. Imagine seeing the fur, the muscle, the terrifyingly long canines of a saber-toothed cat, not as a skeleton, but as if it were merely sleeping. That would be a truly spectacular and perhaps slightly unnerving discovery. Whether the scientific community's collective yearning for a specific dream find biases research efforts or simply reflects the natural human desire for spectacular discoveries remains a point of academic discussion. Beyond the well-known megafauna, the permafrost could hold secrets about smaller, less understood creatures. Think of ancient insects perfectly preserved in amber-like ice, or prehistoric plants that could reveal the subtle shifts in ancient flora. What about early hominin remains? While direct preservation of human bodies in permafrost is extremely rare, the possibility of discovering more ancient human artifacts, tools, or even direct evidence of early human interaction with these specific frozen animals remains a fascinating prospect. Every piece adds to the complex tapestry of our understanding. The future of these discoveries is intertwined with the future of our planet's climate. As permafrost continues to melt, the window of opportunity to retrieve and study these specimens might be limited. On one hand, more will be exposed. On the other, those that are exposed but not recovered quickly will inevitably decompose, lost to time forever. This creates a powerful urgency for scientific expeditions and a responsibility to carefully manage and study what the melting ice reveals. Ultimately, these ancient animals emerging from their icy slumber serve as profound reminders of Earth's deep history and the dynamic nature of life. They are frozen echoes of a world that was, and tantalizing hints of what might still be waiting to be found. Each discovery reinforces the idea that the story of our planet is far from fully written, and that the greatest chapters might still lie hidden, patiently waiting beneath the silence of the ice.
The last echoes of the Ice Age begin to fade now, don't they? As the imagery softens, the biting wind lessens, and the vast white landscapes gently recede from your mind's eye. Feel the warmth returning, a subtle shift in the air, bringing with it a quiet calm. These ancient creatures, locked away for millennia, have shared their stories, their struggles, and their remarkable endurance. They remind us of the immense stretches of time that precede our own brief moment, and the incredible, sometimes brutal, beauty of the natural world. Allow the whisper of their long-ago lives to settle peacefully within you, a quiet lullaby from a distant past. There's a profound stillness now, a sense of deep time embracing you. Let it carry you gently into the quiet embrace of the night. Sleep well, knowing that even in the deepest freeze, life finds a way to leave its mark, and sometimes to tell its tale.